from me. I am Georgia, and I am a research associate at the Center of Research and Technology, Hellas. So I'm here to present to you our work, thoughts, and ideas about obtaining insights for the emotional well-being of cancer patients, using data from their social media and browser histories by utilizing NLP technologies. So let's begin with the connection between NLP and emotional well-being. Well, there are two basic clusters of how we can use NLP for the emotional well-being. First, we can help diagnose the mental issues, and also we can can assist treatment. These are two topics that are very much in research right now, and the literature has shown a lot of results about this. So, about breast cancer. Let's say that breast cancer is, not let's say, this is a fact. Breast cancer is the most common diagnosed cancer right now. In 2020, there were 2.26 million women diagnosed with cancer, breast cancer specifically, and 685,000 deaths from breast cancer. And to put this into perspective, there are 7.8 billion diagnosed women in the last 5 years. 50% of these women are younger than 64 years old, which means that they are living with cancer or they are battling cancer in their most active years of their lives, which means that, let's say, they want to support their families, they're raising their kids, they're having their careers, but at the same time they're having this disease occupying them. And 90% of these women live for 5 years or longer, which means that this issue is occupying their brains and they are having issues with this for a long time. So basically, what we are trying to do, what I'm going to present here, is the work we are doing in the Rebecca project, which is a Horizon 2020 project funded by the European Commission. So the vision of Rebecca is to use real-world data into supporting clinical research on post-surgery breast cancer treatment, as well as support patient management for breast cancer patients. So in more specific, the work I'm going to present is part of the attempt to create a 360 degrees patient monitoring tool using different data sources such as electronic health records, wearables, mobile apps, social media, or other online activities. And from this data, we are trying to create indicators and metrics regarding the behavior, their lifestyle, how is their emotional status, what is the environment they are living in, as well as their medical history. You can understand that women that live with cancer this can affect them and can cause several mental issues and emotional issues. They can have a lot of stress, depression, anxiety, as well as fear of recurrence. You can understand that this is basically affecting their whole quality of life. It is a very big part of their lives. So our goal in this specific work is to try to identify whether they are experiencing any sort of symptoms like this. Why is this a good idea, and is this important to be able to identify these types of signs if they are leaning towards stress, for example? First, it is in the literature you can see that good mental health is very important for the trajectory of the treatment. That means that if a woman is very stressed or anxious or depressed, maybe the treatment is not going to go as well as they would like to. And also, cancer recurrence is associated with poor mental health. So you can understand that proper monitoring of the emotional state and if they are being well emotionally is very, very important for the experts to be aware early enough in order to intervene and provide support or other means in order to help them not go in a really bad emotional state. Specifically for our work, here you see a graph regarding the pipeline that we're going to follow. There are several steps, let's say, and I'm going to present to you in very short and not very technical details. So first, we're gathering data from social media as well as web browsers. And these are basically textual data. They're going to go through pre-processing and the processing pipeline, and we're going to implement some classifiers in order to be able to extract some indicators, such as emotion, sentiment, if they are having signs of anxiety, depression, stress, and more. So, in a little bit more detail, we're gathering data from, specifically in our case and in our project, from YouTube and Facebook, data such as posts, comments, or other reading materials, as well as web browser histories from which we can extract their search queries and the links and the sites that they visited. So why this data? For example, consider a woman that is a breast cancer survivor and experienced a specific event the last days, and she posted it on Facebook. We can take this data and understand if that event was some sort of emotional, if it was positive or negative, and this can give us a sign if they're having positive emotions at the time or not. And from browser histories, if someone is searching very often, this is an assumption, we're trying to prove if it's correct. If someone is searching very often some disease or some symptom they're experiencing or their cancer or anything related to that, maybe when they are considering that they are having something wrong going on with them. So that can lead to stress and anxiety, most probably. Well, I think that everybody, when they are starting to consider that they are having something wrong with their bodies, they are experiencing some sort of stress. So how we are gathering the data? We have created a Google Chrome extension, which basically gathers data from the 3 different sources. The collection is happening and the data is being pseudonymized, so that means that we do not collect any personal information. And of course, since this can be considered as a privacy issue, how are we gathering such personal information, the patients and the people that are using this application and this Google Chrome extension can control what we are monitoring and what we are gathering. They can pause the user tracking in order to say, let's say now I want to search something that I don't want to share with a project. Additionally, if they do not do that, but later on they want to delete something they do not feel comfortable sharing with us, they also have this opportunity. So now we gather the data. What do we do with them? This is classic NLP. We can create different features. Either it can be traditional features such as present-based, frequency-based, or syntax. We can also use lexicons such as emotional lexicons. But also we can do some more current trends to translate, to transform the text into word vectors, which is word embeddings. Most of you probably know what word embeddings are, but I'm going to say a little bit fast. There are 2 different types. It's the static and the contextualized. What is the difference? So let's take an example. Let's say we have the word mouse. You know that the mouse is the animal, but it is also the device that we use on our computer. So in a different context, each word means a different thing. The contextualized word embeddings include the different context while creating the word vectors, the representation of the words into vectors. The static word embeddings do not. Some of the static word embeddings that you probably know that are very popular is word2vec, glove, as well as fast text. And the contextualized word embeddings we can take from using BERT, GBT, or Elmo. And there are more, but they're not as popular. So in our work so far, we are still at the beginning, we have tried to start with understanding emotion, so doing the task of emotion recognition. In the literature regarding emotion recognition, there are a lot of studies that have been implemented in the past, using several machine learning models as well as deep learning models. And there are a lot of good results. And more currently, there are a lot of implementations using pre-trained models such as BERT, which indeed show a lot of potential. But there is a problem. We cannot, no single model can guarantee outperform others in the literature, because how each model performs, it really depends on the preprocessing the dataset is having as well as the dataset itself. We cannot compare models and results unless they are executed at the same dataset. So in our preliminary work, we have addressed a multi-class problem in emotion recognition, as I already explained. We took three different public datasets for emotion recognition, and we merged them into one in order to have some more enriched classes. The classes that we have are 6, and you can see their distribution here. The emotions are sadness, worry, surprise, love, happiness, and anger. And in total, there are around 49K instances. So what we implemented, what different classifiers, we have tried a lot of different things, such as baseline models using machine learning, such as naive Bayes, logistic regression, random forest, or linear SVM. We also implemented CNN, LSTM, and BLSTM models. And out of these, then we fine-tuned BERT, which had the best F1 macro results so far. And we have had an idea to stack and to add an LSTM layer above BERT, fine-tuned BERT, which gave a little bit better results. So these are our preliminary results in our work regarding emotion recognition. Of course, we did not perform any specific and very deep hyperparameter tuning, so there is a lot of room for improvement here. Our vision, as I said, is to be able to identify emotion as well as other signs such as anxiety, depression, and stress, which I do not tackle in this presentation because we haven't started implementing anything on those sectors yet. But you can understand that this vision has a lot of issues and a lot of challenges. It's not an easy task, and it is quite dreamy, let's say. So first, you can understand that there are a lot of privacy issues and ethical issues. Someone might say that us gathering data from social media as well as browser histories can be invasive into their private life. Well, of course, we're trying to address this in the project through several ways, one of which is pseudonymizing the data we're gathering. Since we're talking about women with breast cancer, these women can be also older in age, and they may not use the internet as much or use it very little usage of the internet, which means that we are not going to have any data, which is not ideal. And finally, regarding data, there are annotation difficulties. For now, we're working with public data sets that are already annotated, but when we're going to start using our own data sets that we're gathering from specific women that are breast cancer survivors, we're going to face annotation difficulties because, as you understand, annotating regarding emotion is hard even for a human being from a short text. Imagine how it will be for the machines. Moving on to the challenges, emotional well-being identification in general is not easy. There are many confounding factors, and there is no clear association between the online behavior and the emotional well-being. So this is going to be, we're trying to see if we can have some results, but it is hard to do. Additionally, since not everybody speaks English or writes English in their everyday life, we are going to have to face the several languages problem. Also, since we're talking about a specific domain, which is breast cancer, and let's talk about cancer in general, we are going to have to adapt to the domain and include several different features to our models in order to be more specific to the specific domain. And finally, as you can imagine, in social media or in search queries even, people are not writing their whole life story, they're writing short text. So it is quite hard to understand emotion or the signs of depression or anxiety from the short text. And reaching to the end of my presentation, I'm going to tell you about how we plan to proceed. Of course, we're planning to improve and find new ways to increase our results regarding the emotion recognition. But we are also, as I said, we'll try to to analyze and try to detect depression signs, anxiety signs, or even stress signs. And since we're gathering data, it's not only textual data from the social media, it's also other online activity patterns, such as frequency of search, or let's say the likes and the the reactions in a Facebook post. So we will use all these data in order to or improve our models or create models just with using those, as well as behavioral indicators, such as is this woman walking today, or is she smoking? And these are also part of our project, which we will be able to include in our models. And finally, the evaluation of this work is going to, and the model and the generated data is going to happen in 3 clinical studies that the Rebecca project is going to organize, which aim to improve patient management and patient outcomes, and for example, their quality of life. And the clinical sites of the clinical trials are going to be in Stavanger, Norway, Stockholm, Sweden, and Valencia, Spain. That's why I said that we're going to face the multilingual issue, and these are not common languages and easy to understand. So, yes. And that was all. Thank you for your attention, and feel free to ask any questions now or tomorrow in the poster session.
Thank you very much. We have time for a few questions, yes?
Hi, thank you for a nice presentation. I have actually 2 questions. First one is curious about the patient's perspective. So do you know how much patients are willing to participate in this type of study, or how they are willing to give away their data? And the second point is what could be the end result, or what could be the benefit for the patients in the end? So for example, okay, they might know they are depressed, they use a lot of YouTube and Facebook, and yeah, the system tell me that I'm depressed, and okay, then what can I do?
Yes.
Yeah.
So far, if we are we have a partner in Norway who is an association for breast cancer survivors, and the women that participated and gave us their data are around 25, not many, unfortunately, but we're going to have to work with that. And regarding how we can use this, these are not information that are going to go directly to the patient. They're going to go into a dashboard that has a lot of different information, such as behavioral as well as the emotional state, let's say, indicators. And this is going to be accessed by the doctors. The doctors and the experts are going to be able to see if something is not going as well as it should, or as well as they would like, in order to intervene or support or give early warnings or help the patient in an early stage before something goes totally wrong. The patient will not have access to this information.
Thanks. Are there other questions? Yes.
Hey, thanks for the cool presentation. You mentioned, I guess, that the experiments you've done so far are mostly using publicly available annotated data sets. Like, which data sets are those?
I do not remember by heart, but I can give you the links. They are publicly available, and they are used in some researches.
I'm just curious about how closely they resemble the use case that you're talking about here.
Not close at all. These are tweets. We're just trying to create a general model in order to be able to adapt it to our own data. We could not find a data set that is specific for Facebook, or for example, or YouTube comments or posts, and breast cancer. This is impossible.
One very short question. There is one, yes, coming. Thank you. Sorry.
Thank you for the cool presentation. So I'm actually interested in your data set, and you mentioned you're using the public data set right now. I'm actually curious about what kind of feature are you used to inputting the model? Because you're mentioning queries or comments or website browsing histories, but that would be a lot of text, to be honest. Are you using maybe titles or keywords or something like that? And how do you decide which part of the text do you want to use? And actually, a second follow-up is about the data set as well, because concerning about the privacy, I think you mentioned the pseudonym.
Oh yeah, got it.
de-identification tools. So are you like collecting data? You don't collect the personal data from the first place, or you remove the personal information afterwards?
Okay.
Thanks.
So the second question first. When we got the data from the women, the 25 women I mentioned earlier, we removed them afterwards, but only a few people had access. And for example, I didn't have access to the data that had the personal information. When we're going to have implemented real-time this idea, let's say, all the pre-processing and the processing and the inference is going to happen locally on the device of the person, and we're going to get only the outcomes of the indicators, so no personal information is going to travel on the web. And about the first question, which I forgot, what was it? Yes, the features. So far we're using the public data sets that are a specific text, and it is taken, these texts are taken from Twitter. So it is a small size text. It's not large. We do not have to take specific part of the text. And the most successful implementation so far is using BERT. So we are using all of the text at once. That's it. We are going to try to implement some lexicon-based or adding some extra features, let's say some extra vectors in order to improve our classifiers, but this is a work in progress.
Thanks again to the speaker.
Thank you.